That looks good. Give me a second. Is that good? 12's good? Yeah, I guess 12's good. Hello! Hi. Hi. Let's see. I was using this one. Was I using this one? Okay, cool. I'm back. Yes. Cool. Okay. So, intro to ROS, Robotics Operating System. First of all, let me send this. Cool. Nice. This ROS. Yes, this is ROS. Awesome. So, cool. Happy to have you back. We are back for another cool stream. Let's start. So, first of all, who am I? If you were in the last stream, my name is Charbel. People call me Bullet. You can call me either by my name or nickname. People find my nickname easy to pronounce, so you can go with that. I'm a robotics engineer. I'm also a streamer and a pod leader for the MLH Fellowship. So, yep, I'm happy to be here. Happy to have you here. Let's start. This stream is going to be about ROS, or Robotics Operating System. So let's start. Cool. So let me just prepare my stuff. Let's add this entire screen. Yeah, why not? Nope, this one. Let me just change it to OneNote. There we go. Cool. Can you see this? Yes, you can. Okay. Let me draw something and see how it looks. But yeah, give me a second. Let me just open my cheat sheet, which should be, is it this one? Nope. Give me a second. Nope. There we go. This one here, and let's open up OneNote here. iPad, don't do that to me. Wait a second, Mr. iPad, come on. Yep, there you go. So let me just see if this looks good. What about if I do this? Does that look good? Probably. Shoot, not this one. This one. Can I? There we go. That's better. Yeah, I think that's better. Cool. So, introduction to ROS, or Robotics Operating System. So, what's ROS? So, ROS stands for, again, let's just do this. ROS is Robotics Operating System. Okay, Robotics Operating System is used in a lot of things. We have two versions of ROS, ROS 1 and ROS 2. I use primarily 1. I haven't used 2. If you're familiar with 2, you might see some differences. But yeah, basically it's an operating system used by robots worldwide. It's open source. It's primarily on Ubuntu. Okay, so ROS 2 can be used, as far as I know, on Windows and on Mac too, but I'm not sure how stable it is, but you can use them. Okay, the idea is for it to be cross-platform, but ROS 1, which is the one that we're going to explore, is just for Ubuntu. Okay, so if you want to recreate whatever I do, make sure you're in Ubuntu. If not, it won't work. You can either use a virtual machine or a partition. Don't partition your computer if you're not sure. Virtual machines are easier to use. Okay, cool, nice. Okay, so this is ROS. How does ROS work? So before we dive into how it works, let's just dive into how it's composed. Okay, there's something called nodes. In ROS 1, there is a node called master. Okay, so master is the node that controls the other nodes. Okay, so what is a node? Like, you're talking about master node. Oh, wait a second. We just started. Why do I have a banner there? Okay, cool. So we have a master node. A master node controls other nodes and ensures that communication between all of the nodes is acquired. Okay, cool. So far, so good. What is a node? A node can be anything. Okay, a node is basically a script that is running in something. Okay, and that is doing something. Basically, something. Yeah, I know. Yeah, no. Cool. So let's imagine we have. Do I have space? Yeah. Let's imagine we have something here like a drone. 1, 2, 3, 4. It's like this. Happy face because drones are happy. Okay. Let's say that master node is located in here. Okay. Master node is basically there. It's in the brain. Okay. Every single one of these motors is a different node. Okay. Just for the purposes of this illustration, this would look like this. So we have left up. Okay. Actually it should be right up. Wait a second. Right up motor. Right down, left up, and left down. Okay. Every single motor can be, I said 4. Wait a second, Mr. iPad, don't do this to me. What? Wait a second, let me just refresh this. Why does this happen? Wait a second. Can I do this? Let me just refresh OneNote, because OneNote sometimes just takes time to think. Okay, is this good? No, it's my OneNote. Wait a second. OneNote. There we go. Nope, nothing. Really? Wait a second. Let me just refresh the whole thing. Wait a second. This should be working now. Come on. My internet's okay? Yep. Welcome to OneNote. Yeah, welcome to not working when I want you to. Yeah, basically. Yeah, there it is. Cool. We are back. Sorry about that. OneNote just sometimes just doesn't want to work. Why? I don't know. That's what happens sometimes. Let's see. Let me put this here. Cool. Okay. So we have 4 nodes for 4 different motors. Now, if you have used some drones before, you might notice that under the drone, there is a sensor that tells you how high or low the drone is. So we have an ultrasonic sensor that could be another node. That's a horrible node. There we go. Which is the ultrasonic sensor. Okay. So far, so good. Everything can be a node. Okay. We need it to check stuff. We need it to check the height, to move an object, like move a tire, which is a motor, or is a camera, it's a sensor. It basically computes. Everything's a node. But it has to be connected to node, to master. Okay? So far, so good. No master, no ROS, basically. Okay? Cool. Now, it's fundamental. It's like a cell. Okay? So a single cell from the human or from any animal. It's the basic computation unit, or like the basic unit of life is a cell. Same thing here. If there is no node, there is no connection. Okay, so far so good. So far so good. Cool. Now, we have 2 types of nodes. We have nodes that publish. Okay, let me just grab another color. Publishers. And we have subscribers. Okay, so we have subscribers and publishers. Okay, we'll go into code, I promise. Let's just get the basics first. Okay, publishers, as they are known, is nodes that talk. Okay, speak out loud. They say stuff. Okay, subscribers listen. Again, publishers talk, subscribers listen. So what does this mean? Let's say we have a node in this drone that tells us the height. Okay, it's the sensor. Okay, the sensor that we have under the drone that tells us how high or low we are, that's a publisher. It'll tell us, hey, you are 4 feet or 4 meters up, 4 meters or like 2 meters up, and it will tell your motors, which are here and here and here and here, if they have to like add speed to it so it goes up or down. Okay? Motors, listen, which are subscribers to that node. Okay, so far so good. So far so good. Okay, publishers, subscribers. Okay, we'll see that in the code. Bear with me first. Okay, cool. Now we have topics. Okay, topics. Wait a second. Let me just scroll down. Cool. Topics are the communication channel that allows nodes to communicate. Okay, so basically, we can send here topic is a string. Probably this is a topic called, I don't know, height. And it sends int. I don't know, whatever we need it to be. Okay, but a topic has a name and it's a channel, okay, where nodes communicate. You can imagine this as having a radio, okay? So you click, you have to be, I don't know, at a certain frequency. You want to talk to the other radio. It has to be on the same frequency for it to listen. If a node is not subscribed to a topic and the other node is talking through another topic, there's no communication between nodes. So no one will know what's happening. Okay, so far so good. That's the basic of it. Okay, cool. And they send messages. Okay, basically like a walkie-talkie. Cool, cool. So far so good. Cool. Let's see it in action. Yeah, let's just minimize this. Cool. Google Meet. Let's see. Let me just remove this for now. Get myself into the meeting, which was happened before. Join now. There we go. That's it. That's me. F11 here, but not here. F11 in this part over here. Cool. Now change to my good computer, or my other computer, which is Ubuntu. Okay. So again, ROS runs in Ubuntu, at least ROS 1. Okay. I'm using a version of Ubuntu. I'm sorry, a version of ROS, which is ROS Noetic. ROS Noetic runs on Ubuntu 20.06, 04, something like that. Give me a second. Cool. Voila. Let me just re-enter the meeting. You mouse go here. You mouse rejoin. Connect to this. There we go. Ask to join. Nope, nope. There we go. That's me. Yes. Cool. Okay. Now let me just minimize. Thank you. Thank you. There we go. Minimize this. There we go. Now we can see my whole screen in 5 seconds. 3 seconds. Can you? Yes. Cool. Okay. Pizza. Because why not? Because why not? Okay. Image. This was the past. Cool. That was the past stream. Okay. No need for this. No need for this terminal anymore. No need for this. No need for this. There's a doggo there. Yes, I know. Cute doggo. Okay. Terminal on. For ROS, we use a lot of terminal. Okay. I recommend you using Tilix, which is a terminal that you can basically create more small terminals in it. Okay. 1, 2, 3, 4. There's another one called Terminator. I don't like that one very much, but you can use it too. Cool. Now, okay, what should we do now? Don't panic. First of all, let's just start with the basics. Basically, go install ROS noetic. Okay, you have to follow this set of instructions that are here in the web page. Ubuntu. Yep. Okay, and you're good to go. Okay, so I won't do that because I have ROS installed. It takes roughly 10 minutes to install every single package. Just be patient. Okay, cool. Now I'll just skip this part, okay, because I already have it. Let's go into the good stuff. First things first. How do you start with ROS? Like, what do you do? Let's just start with the first command, which is the most important one, which is what? Wait a second. I just got out of the Docker stream and I just forgot everything about ROS. ROS core. Yep. Cool. So we have ROS core. ROS core creates the master node. Okay? If we want to run something in ROS 1 and we don't have ROS core on, it won't run. Okay? It won't run. Wait a second. There we go. It won't run because it's not connected to master. Remember that if we don't have a master, neither node can talk to each other. Okay, so there'll be an error. So let's take a look at something interesting. When you install ROS, you have lots of things. One of the few things that you can play with is you don't need a robot to use ROS, by the way. You can simulate stuff. Let's do ROS run, which is a command. Okay, ROS run. Turtle sim, okay, and then turtle sim node. Okay, let's go back and see what this means. ROS run, it's a package, it runs packages of ROS. Okay, we won't be creating packages of ROS because it's an intro. In 2 hours, we won't create that. Turtle sim, that's the name of the package, and the turtle sim node, it's the name of the file that we want to run. Okay, what does this do? Cool. Oh, it gives us a little turtle. Okay, ROS's let's call it image is always a turtle. Okay, every single ROS version is a different turtle. Okay, so if I close this one and rerun it, you'll see a different turtle. Okay, cool. So they just wanted to make sure everyone knew. This is a 2D robot. Okay, it goes left, right, up and down. Okay, it doesn't fly, so it's a 2D robot. Okay, we can control this robot. Okay, voila, that's it. Just kidding. Cool. Now, what can we do with this? Just to make sure we got this clear, I'll just Control C the master node. There is no master node. Okay, I'll try to run this. Let's see what happens. Ah, see? Interesting. It says failed to contact master. Okay, ROS 1 needs master. Okay, ROS 2, I think it doesn't. I haven't used ROS 2 to be honest, but ROS 1 needs that. Okay, ROS core again, and we run turtle sim here. Cool. So far, so good. Nice. Now, let me just control always on top. Okay, so we see it. How do we know which nodes are active? ROS node list. Ooh, cool. We have 2 nodes. ROS out, which is the node listening to master. Whenever we say, hey, master out, which is Control C, that's the node that is listening. And turtle sim, which is this thingy. The more stuff you add to it, the more ROS node gets bigger. Okay, like the list gets bigger. Okay, cool. How do I know which topics there are? Like, I want to know if my node is talking to the other node. Which topics are available? Do I need to create new ones? ROS topic list. Okay, we have ROS out. If you see, it's the same name. ROS out AGG. We have turtle1 cmdvel controls the velocity command, color sensor, and pose. So these 3 topics come from turtle1, which is the little turtle, and those are the topics. Again, topics are the channel of communication between one node and another one. Okay, again, like your walkie-talkie. You have your walkie-talkie, it has to be at the same frequency as the other one for it to receive the messages. Okay, Same thing. Okay, cool. Juice that if you were in the past stream, you might know it's not good, but I have to drink it. Really not that good. It just said gamer and I just bought it. Why did I buy it? I don't know. Marketing. Cool. Okay. Now, that's how it looks, okay? It kind of looks that we don't have a starting point. Let's create a starting point. Control C is to basically end stuff that are running in Ubuntu, okay? Or Linux, basically. And Mac, too. Let's go. Let me just see if I have something here. Streams. Oh no, shouldn't be streams. Yeah, no. Let me just double check something. CD, Catkin, SRC, LS. The streams, here it is. Okay, cool. Intro to ROS. What do I have here? Wait a second, because this is from the past stream, from a stream that I did before with ROS. Yep. Okay, and this is the hand tracker. I don't want a hand tracker. Nope. Okay, cool. No. Let's just create a new one, okay? This will be messy. LS CD. Give me a second. No, CD streams, and then let's do I don't know, ROS2, and then CD ROS2. Oh shoot, code dot. There you go. Cool. Okay. Good old Visual Studio. Nothing more. Okay. Now let me just explain something. When you're working with ROS, every single script basically that you create has to be in Catkin SRC. Okay, every single thing. If not, ROS will not understand or will not locate that specific script. So it has to be there. Okay, if I put it in desktop, it won't work. Okay, careful there. Cool. Okay, now we are in this one. Let's see how nodes talk to each other. Okay, let's create one called listener.py. You can write it in Python or C++. Okay, it's up to you. I like to use Python. If you want stuff faster, use C++. Okay, cool. First things first. Well, that's like the most important part of a Python ROS script. If you don't have ROS.py, it won't work. Okay, cool. From std messages, that message import string. What does this mean? From standard messages package inside of ROS dot message, give me the string type of message. Okay, we'll be talking with strings from or like between these two nodes. Okay, for now we can talk using integers, floats, or custom messages that you can create. Okay, cool, nice. Okay, for the listener as your brain, it has to be looping every single time, waiting for data to come. Okay, so you don't see it. Your brain does it for you amazingly. Your brain is recording every single thing, and it's like a while loop that never finishes. Okay, it's like a while loop. And whenever you get data, your brain activates, processes the data, and does something with it. Okay, I don't know. If you listen pizza, then you probably get up and go get a pizza. See? Yeah. Okay, cool. Is this streaming on YouTube? Yes, YouTube and stream. YouTube and Twitch. Sorry. Yeah. Cool. Okay. Is this better? Probably. Cool. Now, what does that while loop mean? Like, how do we do that? Well, we define something called a callback. A callback is a function that will always be active, waiting for data. Okay, so far so good. We just do ROS.py dot loginfo. ROS.py dot loginfo is like a print without interrupting. Okay, so careful with interruptions. when you're working with robots. Okay, so if you print something, it could add a little bit of a delay. That delay could be very influential in your decision with the robot. Okay, so if you are connected to a camera, you added just a teeny tiny bit of a delay, the frames just get stuck. Okay, careful there. Okay, robots are a little bit special, I know. We do an F string. I heard this message. Okay, cool. That's it. Okay, cool. Now let's do def listener, and we create a node. Okay, we cannot have something in ROS without a node. So what we do is ROS.py dot init node. Okay, this node can be called anything. Let's do listener. Okay, why not? Anonymous equals false. Careful there, huh? Anonymous. Anonymous. There we go. Is it? Yeah. Okay, cool. We don't want it anonymous. It means that we don't want, or we want it to be able to be seen and by name from other nodes. Okay. Oh, this is a great question. I do have. Where's my? Wait a second. This is a great question. Any recommendations on Udemy course on ROS? Yes, I can share one, but at the end. Okay. But yeah, I do have one. Cool. Nice. So, this is the node. Now, remember that we have subscribers and publishers. Okay. This node will listen. It means it has to subscribe to a topic. Subscriber equals ROS.py dot subscriber. Careful with the capital S. Okay. What do you want to call the node? I'm sorry, the topic. Let's just call it chat. Why not? Chat. What do we expect? We expect a string. Okay. So if we try to publish an integer in chat, won't work. Okay. We have to publish a string in this case. And what is it that's going to activate when we get data? Okay, makes sense. So again, we create a subscriber that will listen to a topical chat. It expects a string, this type of string, and it activates callback whenever we get something. Callback will say, I heard message. Okay, cool. So far, so good. Nice. ROS.py, the spin, it's like, it's like a loop. It's like while true. Okay, cool. And if double equals under main, cool. So far, so good. Okay. So we will create the listener. We'll activate it when we need. Okay. Cool. Other side. It's listener talker.py. Okay. Cool. Again, with talker, same thing. Import ROS.py. First things first. And same thing. From std messages.msg import string. Cool. Okay, same thing. Now, this one is going to talk. It's going to send data through chat. Okay, let's do that. So def talker, and we create first the node. Again, no node, it doesn't work. Okay, node equals ROS.py.init node. This one we'll call it talker, and it's not anonymous. Okay, anonymous. I've never used an anonymous true. Like, I have to be honest, I don't know what's the big difference. I've never used an anonymous true. Okay, and publisher equals ROS.py.publisher and chat. Oh, let's do that. Why not? Okay, chat with capital C, by the way. string. So we are using chat with capital C. I know it's an error, but I just want to see it crash. String and okay. A publisher can have a queue size. A queue size is like the amount of messages that you can have stacked before it starts losing data. Okay, I always use 10. It depends on your application. If you are connected to the drone, for example, and you're waiting on images, have a queue size larger so that if you lose some frames, they don't go to waste. Okay, so you have them stacked. Okay, cool, nice. So, oh shoot, we have to have something called rate. Okay, rate is, wait a second, ROS pi.rate 10. It's the rate of communication. Okay, if you don't add a rate, it's not that bad for these projects. If you're talking to a drone, a robot, wirelessly or by wire, then the rate fluctuates and you might lose data, or it might be very fast for your computer that it might crash. Okay, careful there. Cool. It's at 10 hertz, so that's fine. While true, actually, while not ROS pi that is shut down. Okay, while ROS pi is on, okay, publisher that publish. Okay, basically, let's talk, let's say something. Happy hacking. Careful, huh? Hacking. Happy hacking. And rate that sleep. Yep, T. So with rate, we control the rate of communication so that we don't overload or underload the communication channel. Okay, cool. Let's do if the new name double equals the domain talker. Cool. I know what you're saying. This is not going to work because chat has the capital C. Let's just see how you shouldn't do it first. Go to your terminal. Let's copy, let's do cd catkin src streams and then ROS2. There we go. Control L here. Okay. First of all, master node. Okay. Let's put the master node here. ROS core. Okay. Master node is on. Everything else can be used. Okay. You run it as normal Pythons. Okay. So we have Python3 listener.py. Should it be doing something? Nah. Why? Because nothing is being sent through chat. And remember, if there's nothing in listener, see, it subscribes to chat, waits, and callback is activated whenever we send a message. Nothing has been sent, so it'll do nothing. Yeah, it's like your ears, basically. If you don't listen to anything, your brain isn't, it's not that your brain is not working, it's that it's like in a standby position. Okay, cool, nice. Python3. Great. Rate. What? Always happens. Why can I, it was weird because last stream, 0 errors. This stream, first error. Rate with capital R. Okay, cool. Why? I don't know. Cool. It's talking, but this one's not listening. Let's double check. ROS topic list. See that? Double chat. One with a capital C, other one with small c. Like your walkie-talkie. It's not the same having 94 hertz. Let's just say hertz, okay? 94 hertz as 95 hertz. It's not the same channel. You cannot listen to each other. Let's change that. Control C this. Small c. rerun it. Ooh, cool. See that? Happy hacking. So it's talker is talking, listener is listening, and whenever it listens, it's doing something, and that's what the callback is. Okay, cool. So far, so good. So far, so good. Nice, 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 nice. Okay, cool. Now, Control C this because the computer will run out of memory. There we go. Control. See this? Master is running. If there's no master, let's just try it again. No master. Unable to register with master node. Okay. No master, no node. Okay. Cool. Cool. Nice, nice, nice. So, come on. Control C. No, 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 no. There we go. Cool. Okay. So, that's a little bit about how nodes work. It's fairly simple. Like, it's really simple. We didn't do anything. We just send the string. So let's do something more interesting, okay? Let's see. Can we go into the main project already? Let's see. What time it is? I think we can. Let me just do listener talker. Yep. Let's do it. Cool. Okay, remember the small turtle? Actually, let me just show you something before we go into the master or like the good project. If we do ROS launch, turtle 3 gazebo, turtle bot 3 empty world.launch. I think I'll get an error. Yeah. Wait a second. I don't remember. Export burger. Yeah. This is the one. Wait a second. I need this first. So this little robot here, it's called a turtle bot. Okay, turtle bot. So it's made. Yeah. Okay. So wait a second. Is it the same command? It should be the same command, just in case. We have one in my, like, I don't have one personally. In my university, there's one that you can use. They sell it online, okay? So you can simulate robots that you don't have, okay, physically. And basically, first of all, you have to simulate them because robots are not cheap. And if you mess something up, it happens. I've burned stuff. But it's better if you try it in simulator first and then you try it in the robot. It should act the same, okay? Cool. We have a question here. It says, in case of reconnection nodes, do you initialize the same configuration or it will be different? It would be the same, okay? So let's say that I'm connected to this robot. It has a Raspberry Pi. So if I connect to it with my computer, it should be the same thing, okay? If you're connecting wirelessly to a robot, you have to be careful with the IP addresses to be the, like, you have to configure some stuff, but it should be the same wirelessly and wiredly, okay? Cool. Now, let's go and do this, okay? Control V. There you go. We exported. We wanted the burger. The burger is the one that's larger. There is another which is called a waffle. It's like like a little bit bigger, but not as tall, okay? Let's launch. What? Wait a second. ROS launch. Where did I turtlebot? Turtle. Oh, it's turtlebot 3 gazebo. That should be it. Cool. Master node is initialized by its own. Okay, so this has something called a launch file, and it has like configurations that allows it to start stuff without us telling it to. Okay, cool. Gazebo is ready. Ooh, there it is. See this? How can I? There we go. So this is Mr. Burger. Okay, Burger is a robot. It's a turtle bot that we can control. Let's double check that. ROS node list. Ooh, cool. We have Gazebo GUI and Gazebo. Okay. ROS topic list. We have more topics. Command velocity. Okay, we have odometry. We have lots of things that we won't be using all of them, but we are interested in CMDVal. Remember CMDVal? That's interesting. Wait a second. Is it the same CMDVal? Let's just wait for it to. Gazebo always takes time to just shut down. Just give it some time. Come on. Should I? There we go. Cool. Now, ROS core here. Careful. No, not this one. It was ROS run. Turtle sim. No. There we go. Okay, we have this simulator of this small drone or robot. Okay. And what if we do ROS topic list? Interesting. See that? It has the same name. This means we can control two different robots with the same script. And that's what makes ROS really cool. What it makes it cool is that we can control different robots with the same script as long as they speak the same language. It means they speak in the same topic. CMDVal is a topic developed by ROS, okay, that controls velocity, okay? CMD, command, val, velocity, okay? Drones have CMDVal. Robots, like the TurboBot, has CMDVal. What does that mean? It means that someone from ROS, someone that said, hey, I want my robot to be compatible with CMDVal, wrote all of the drivers by hand and made it so that it's compatible. So if you see a robot with CMDVal, it means it can be connected with another one that runs on CMDVal too. Make sense? I'm not sure. It's just compatibility. Okay, so you can use a drone, a robot, and I don't know, Roomba, let's say, and I don't know, let's say a 3D printer. Okay, let's just say stuff. If they all hear and listen with CMDVal, you can use the same script. Now, let's just be logic here. You cannot fly, I don't know, a robot that's on ground and that's not a drone. Okay, so you can use probably different 3 types of rovers made differently with different hardware, but they're all optimized for CMDVal. You can use that. Okay, that's really cool. Nice. And we'll get to see that actually. So now that we saw that it's the same thing, let's write some Python. Okay, cool. Now let me open my cheat sheet as always. Cool. Okay, let me do this. Nice. I think we can do that. Okay, cool. New Python. Let's call it turtle command.py. Cool. Okay, nice. Now, Control V for this. Cool. Do we need the shebang? I don't think we need the shebang. Okay. First thing, import ROS.py. First things first. Oh, cool. Now, remember that we got the string from this type of message? Let's do the same thing with some other things. From geometry messages, dot message, which is another type of messages, import twist. What is twist? Twist is a type of message that is XYZ and that you can add values to XYZ and velocity. Okay, we'll get to see that, but that's what it is. Okay, so we're not sending strings. We're sending a type of message that controls speed and direction. Okay, so far so good. It's kind of confusing. We'll take a look at it. Okay, import sys. Do I need select? Yeah, import select terminus and import. Okay, so all of this here okay, we will try to control the turtle with our keyboard, okay? For the keyboard, we need these ones, okay? Just don't freak out. That's how the script is done, okay? Cool. Let's just map our keys. Keys equal W, okay? A, S, oh, come on, S, D, okay? We'll add K, L, and Q, and I'll tell you, we'll see what these will mean, okay? Cool. With ROS, it's always convenient to create a class. Just because it's easier to import stuff. When you have lots of nodes, you have different classes, you can compute and just import some things from the class. It's super helpful, okay? Let's create a class. Usually when it's something that will be operated by you, it's called teleop, okay? Or teleoperation. Let's call it that, teleop turtle, okay? Def, init, okay? Self, we don't need anything more. Let's start with creating the node. Again, no node, there's nothing, okay? So that node equals rospy.init node. Let's just call it control. No, there we go. Now, anonymous moose equals false. Cool. So far, so good. Okay, cool. Nice. Self.publisher. Okay. This thing will talk to the drone or to the robot that will be listening. Okay, so this is a publisher. Self.pub equals rospy.publisher. Careful. Remember what I told you about topics? Let's first start talking to the 2D robot, okay? Like the little turtle. So, ROS core, ROS run this one. Okay, it's on. Let's see, because I usually don't remember the names. So let's do ROS topic list. Okay, keep in mind this name, okay? Let's just copy this. Let me just get rid of this end. And this, turtle1 cmdvel, okay? So it should be slash turtle1 slash cmdvel. Was it like that? Not sure. Turtle1, oh, come on. Turtle1 cmdvel, turtle1 cmdvel. Yes, that's true. Remember, this next argument is what are we going to send? Like, what does cmdvel expect? It expects a twist. Twist, remember, is the type of message. In this case, it's a geometry message. It means it'll give us speed and direction. Okay, cool. And should be the queue size 10. 10, you know, why not? It's not something that we are connecting to another robot. It's basically, you know, it's just it. Okay, cool. Key. Again, don't forget the rate. Self.rate equals rospy.rate in 10. Self.msg equals twist. Okay, so in this case, twist is not created. Twist has to be modified. Okay, so we import twist, we modify it in the Python, and we send it. Okay, that's how it works. And self.settings, this is just for the keyboard equals to mios.dcgettattr. This is just weird, but it works, so I don't change it. sys.stdn. Okay, this is purely for the keyboard, okay? You'll get to see that in a second. Cool. So the next thing is get key, okay? Cool. So let's just, this is basically a copy paste of my cheat sheet. What it does specifically, I'm not sure. I just know it works. What it does is it takes my inputs without interrupting the running script of ROS. Okay, that's what it does over the hood, under the hood, I'm not sure. Okay, cool. So tty, give me a second. That's set raw. By the way, you can find this one on my GitHub too. sys.stdin.file no, like this. Select that select. Should be brackets sys.stdin brackets. Again, I'm not sure how this works. I know it does. So I'll just get over it. sys.stdin read, oh shoot, dot read one. Cool. Termios dot dc settattr. I know it's really weird. Just bear with me for a second. Dot stdin termios dot what tcsadrain drain. I know. Whoever wrote this function's name, let's just change those names. But yeah, shout out to Termios, whoever wrote Termios. Let me just double check. tcsadrain, yes. Self.settings. Is it settings? Yep, cool. There we go. Okay. It's over. Okay, cool. Now, let's get to the fun stuff. Def till up. Self. Okay. So, first things first. Yes. +1 on this one. That person must have been drinking the same drink. Yeah. It's such a horrible drink that it inspires those types of names, okay? Don't drink that drink. I won't say which drink it is. I'll just say it says gamer and it says fruit punch. Not good. It tastes horrible. Like I just stopped drinking. Okay, cool. While not, ROS pipe that is shut down. Means while we are on the air, shut down. Key equals, first of all, we get the key, okay? Self.get key. Okay, so basically we're calling this function here, okay? Cool. Now we got the key. Now, remember I said twist message is not created, but it's in place, it's modified. Okay, so here's the thing. We have the default values. Okay, so it's self.message. Okay, that linear.x, which I'll explain in a second, okay? Self.message, that linear dot y equals 0, self.msg dot angular dot z equals 0. Okay, what does this mean? Like, it's weird. Okay, cool. So remember our robot is a 2D robot, okay? We have, let's just, I have one node. Let's just use one node. Okay, let's see. One node on, there we go. Cool. And is one node working now, please? Let's see. Should be. Yes, can you see this? No. Yeah, great. Wait a second. Why is one node like this? Why always one node? Cool. Can you see this? Yes, cool. Okay, nice. So, and I will say the same thing about one node developers, huh? They should be they probably are drinking the same drink, and that's why network is not good. Okay, cool. So our robot is basically trapped, okay, like us, or not like us, but it's trapped in a 2D dimension, okay? It means it can move up and left or down and right, okay? It cannot move Z, okay? Z is up. or like 3D, okay? So it won't move like this, okay? So this little robot is trapped in a 2D dimension. We humans in this universe, we are trapped in a 3D dimension, okay? We cannot think or imagine a 4D dimension and like over that, okay? That's how it is, okay? um, cool. Now, what we are saying with self.message.linear.x, it means I want you to either move that way or this way, okay? Self.linear.y is either that way or this way. Make sense? Okay, so far so good. And we have another one, which is angular z, okay? So I'm not a big drawer, but here's a turtle, okay? 1, 2, 3, 4. Okay, happy face. There you go. Cool. Okay. The turtle has here, okay, like this. Okay, this is z. Okay, so z, we cannot move into z. That will mean, just basically getting out of the of the screen. Okay, so but we can move in an angular direction. It means it can rotate in its own axis. Okay, that's what angular z means. It's not a linear movement, it's an angular movement. Okay, so it rotates basically. Okay, cool. Just wanted to make things clear because at first sight it's not that intuitive, I know, but when you're used to robots you have to deal with these things. Cool. Okay, so that's what this line is. Okay, cool. Okay, so let's see, let me get my cheat sheet again. There we go. Okay, so now that we have these values, let's just see what keys will move what. Okay, so check if valid key. Okay, cool. Now if key in keys. Okay, what are keys? Remember, keys are this ones. Okay, if I don't know, if I press on E, shouldn't do anything. Okay, cool. If key in keys. Now if key double equals W, okay, W, we want it to go forward. It means self dot message dot linear dot x equals, or yeah, equals 1. Okay, just move at 1 unit. Okay, which unit it is, I'm not sure for this robot, but let's just say 1 unit at a time. Okay, cool. Same thing. If key double equals s self dot msg dot linear dot x. What's happening to my typing? There we go. Equals -1. Okay. Okay, this is an interesting question. Shouldn't it be a while loop for pressing keys? No, because we will store the value. The value will be stored. So you don't have to keep it pressed. You just press it once and it'll be 1. Okay. If we press S, it'll be -1. So go back. Okay. We can make it a little bit more intuitive of adding +1 +1 +1 +1 to make it even faster. For this robot, I don't recommend it because the window size is too small, and when it hits the walls of the window, it sends you a warning message. So it's spamming a lot. So yeah, it's fine with it because it stores the value. Okay, good question though. Cool. Okay, if key double equals a, basically self dot msg dot linear dot y equals 1. Okay, it means move sideways. Okay, same thing for key double equals d self dot msg dot linear dot y equals -1. Okay, so we have k. So if key double equals k self.message.angular, careful here, .z equals 1. Okay, so it'll move in its own axis. Okay, if we don't add the angular, we add a linear z, it'll throw in an error like, hey, I can't fly. Okay, make sense? Cool. So same thing for if key double equals L self.message.angular .z equals -1. Okay, cool. And if key double equals Q, then break. Okay, so far so good. Cool. Now, we checked this, and now, after this, let's publish, let's talk, let's tell the turtle what to do. So, self.pub, okay, that publish, self.msg, okay, cool. Again, we didn't create twist, we just changed it, okay, cool. Now, if name double equals, oh, this is, there we go, under main, there we go, turtle equals teleop turtle turtle, there we go, turtle dot teleop, there you go. Was it teleop? Wait a second. Yes, and was it teleop turtle? Yes. Okay. Should work, technically. If we didn't get the names wrong, should work. Cool. Let's try it out. Let's clean here our, there you go. So first things first, master node, which is ROS core. Okay, cool. It's okay, no reds, which is good. Now let's do ROS run. Okay, turtle sim node. Okay, there's little turtle, always on top. Okay, cool. Now let's put it here. Python 3. What was it? Turtle command. Cool. 3, 2, 1. Okay. It's not doing anything. It's waiting for us to press on the keyboard. Ooh. See that? W. Okay. S. Okay. What about A? Okay. That's A. So that's linear Y. Okay. So X for, if you look at it like in this way, X is this side over here, which is the width. Y is the height. Okay. W, A, let's do a D. See that? Okay. That's linear Y. Okay. Let's do linear Z. Ooh, look at that. It's like 45 degrees, probably. Let's do that again. Yep. Yeah, 45-ish degrees. Okay. See that? So we can do stuff like this. I'm pressing on 2 keys at the same time. It looks horrible. What you can do is add control, is add AI, is add lots of stuff to your robot so it becomes a little bit brighter, smarter, if you want to see it that way. Okay, we won't do that sadly in this stream. I did it once. It was cool. The robot was able to basically move by its own to different coordinates. Okay, but there it is. We're talking to a robot, but I promised you something. I said we can use the same script for the other turtle. Let's do that, okay? Let's do this. Control C this thing. Oh, Q. There you go. Q. There you go. Nice. Now, will it work? Let's see it. Nope. Where's the command? There we go. Cool. I think it'll, wait a second. I hope it doesn't clash. There we go, it didn't clash. Okay, cool. There's Mr. Robot. Let's just look at it from this angle over here, so it's easier. So if you look at it in this way, it's basically the other robot in a 2D dimension, because this one cannot fly. If this robot was a drone, we could lift it with Z linear, okay? It doesn't, so we just look at it from this angle. Okay, cool. So let's do it. Python 3. What was it? Turtle command. Wait a second. Turtle command. Okay. Python 3. Turtle command. 3, 2, 1. Cross the fingers. Huh? What? There is no master node. It should be. Yeah. It clashed. Okay. So here it says ROS master, but we created a master with a master and it clashed. So let's remove this one. Sorry about that. It happens. Sorry. Gazebo takes time to close. Let's give it like 2 seconds. Come on, you can do it. Oh, come on. There we go. Cool. Let's do that again. ROS launch. It should, there it is. It should create a ROS master. Okay. It won't clash because we don't have another master here. My bad. I'm sorry. Cool. Let's do that again. Okay. It's running. Let's see it. Okay. It should move when I click on W. Okay. Press on W. I pressed. I promised I pressed. Okay. I'm pressing, but why is it not moving? What do you think it is? Like I told you, it should move because it's the same communication channel. It's the same topic. Or is it? ROS topic list. Okay. Let's take a look at that. Did you run the command script? Yes, I did. It's running. Okay, so it's you can see like the little thingy. It's there. Like I'm pressing on the key and it's not doing anything. But wait a second. Look at the name of this topic. It's CMD-val. And we are sending stuff to Turtle1 CMD-val. Huh. Remember what I said? Careful with the topics. Okay, Q. Okay. Let's fix that now. Let's get rid of this. It should be /CMD-val. Let's take a look. /CMD-val. /CMD-val. Okay. Same script, just a teeny tiny tweak on the publisher, but should be fine. It's not another script. Let's run it. 3, 2, 1. It's running. Okay. It's waiting. Let's do this because it happens very fast. Okay. This is the one that we want to focus. Always on top. Okay. W. Ooh. Okay. Hey, wait. What? Wait a second. Okay. So it's not optimized for this robot, but it's what? Okay. So this is something interesting that we have to see. Even though it works, remember I told you that different robots have different drivers? Okay, so one robot is just a simulation, and this one is a little bit more complex. As you can see, it has 2 tires. Every tire has its own motor. Okay, so every engine or every motor that it has, it's running at different speeds. That's why it's happening this way. Now, what if we do, like for example, L4, there we go. See, it changes everything. It's rotating in its own axis because it's a different command. So K for the other, okay, L, K, and you can see it actually moves. It's not that it's only rotating, you can make it move by, just like baby steps. Okay. W. Okay. See that? It kind of fixed it. Let's just do S. Get back here. Why does that happen? Oh, goodbye. Shoot. Wait a second. Wait. There you go. Okay, we lost it. Wait. L. I said L. There we go. Okay, cool. So why does that happen? Every single motor that we have has its own controller, okay, that is sending signals. Every single Python script can work with your robot if it follows the same logic, but it's also important for you to see if the engines or motors are also following the same logic. Okay, for one, it was easy to say WASD and just go forward. For this robot in particular, what's happening is going forward is adding voltage to two different motors. Okay, so we have to control that. Okay, in the end, this works, that's what I wanted you to see. And in the end, it's rotating it in its own axis because one tire is going backwards and the other one forwards. We just have to tweak the Python so it works with both of them. Okay, makes sense? It works. You just have to tweak a little bit. Okay, cool. By the way, let's just take a look at waffle and burger. So let me Control C this, Control Q, L, and L here. Wait a second. Let's, oh, come on. Because it's always on top. Wait a second. Move, should it be? Yeah, there you go. Cool. Okay. Now, let's get Mr. Waffle. Okay. Control L, Shift Control V, export to the vault, burger. No, we said waffle. Waffle. There we go. And let's rerun the whole thing. I've worked with waffle before. I've never worked with burger. Okay. This is waffle. See, it's just a teeny tiny bit different. It's not as tall. It's larger. Okay. It depends on what you're going to use your robot for, but same thing. It's the same robot. We can do the same thing. Just careful because waffle is a bit unstable too. W, see, it follows the same. See, it just follows the same pattern here. L or K, there you go. It's doing the same thing. It's a different robot doing the same thing with the same script. That means you can control lots of robots in the same communication channel, which is CMDVAL. And luckily for us, usually all robots use CMDVAL. Usually. Some of them don't, but they usually do. Cool. That's it. That's basically it. Now, you might say, hey, this is just a simulation. I get it. Like you can add stuff to it, just add this thing here. We can add like a sphere here. You can add more stuff to it. We won't dive into the simulation today, but basically this is how the robot would be doing, or what it would be doing in real life. Okay, so if you see that in simulation it works, you can connect it to the real life robot and use it. Just be careful and simulate it first. I've broken so many robots that it becomes comical, but it's expensive. Okay, so simulate first and then real life. Okay. Question: is it possible to add autocomplete on VS Code? It would be more helpful for beginners. Yes. I don't like autocomplete. You know why? Let's see. So if I want to type something, let's say teleop, if I don't have autocomplete, then it doesn't add like everything that it finds, which is what I hate about autocomplete. And no, I know that for beginners, it's easier. But let me tell you something that you won't like. Do not never use autocomplete. Okay? For programming, don't use autocomplete. Only if it's something like HTML, okay? Which is kind of okay because it takes a lot of time to write. But if it's Python, get used to writing Python every single thing. It sticks more, okay? I know it's overwhelming and it looks easier with autocomplete. Myself, that I've been programming Python for a lot of time, just remove autocomplete. C++, Python, whatever you were using, Ruby, don't use autocomplete, okay? It's a personal thing. You can add it, yes. Usually VS Code comes with autocomplete by default. I removed it because I don't like it. Because it sometimes I just hit enter because I just want to change the line and it autocompletes with something totally unrelated. And it's like, dude. So yeah, that's why. But yeah, again, you can use autocomplete on VS Code. When you install VS Code, it's natively autocompleted. Okay, makes sense? Yes. Cool. Okay, nice. So what can we do as well? This was the main project. Okay. What else can I show you? Okay, this thing. Okay, wait a second. Explain role, pitch, and yaw. Okay, over. Cool. Okay, so in robotics, okay, there is something called. Oh, sorry. Q. Thank you. Q. There we go. Can I? How can I? Always on top. Always visual workspace. No. Down? No. What? How can I? What? What? I didn't know you could do that. Always on top. Okay, no. Thank you. Cool. Okay, so we have something called what? Wait a second. All windows. Ah, there you go. Cool. So, we have something called roll, pitch, and yaw. Okay, this is more for drones. Okay, what does this mean? So you have, okay, what we do is these three fingers like this. Okay, like a plane. I don't know, like this. Okay, you have x coordinate, y coordinate. I'm sorry, x, y, and z coordinate. Z is always up. Okay, so I'll just do it with 3 pens, but here it is, x, y, and z. Okay, so this is how I can draw. Wait a second. It's just so much easier. Wait a second. There we go. So we have roll, pitch, and yaw. One note, Mr. One Note, please. Cool. So can I? Yeah, let's do it here. We have roll, we have pitch, and we have yaw. Okay? So roll, pitch, and yaw are different types of movements that you can do in a robot that flies. Okay? Roll is the x-axis, okay? Pitch is the y-axis, and yaw is the z-axis, okay? Am I correct? Should be correct. Yeah. Okay, cool. So basically, roll should be like this, pitch, and yaw. Okay, yaw is like this. Okay, like that. Okay, cool. So what we were doing is controlling the yaw of our little turtle bot in the Z. We weren't controlling the roll nor the pitch. Okay, careful with that when you're working with robotics, because in the end, moving in Z with a drone means rotating. If you move in yaw, you can go down. Okay, so if a drone is flying, you move yaw, you do this, it goes down. I think the drone won't let you do that, but if you hard code it to not obey its commands and obey yours, you can, and I've done it, you can break drones, and it's not a good idea, but hey, it's fun to watch, okay? Just careful with that. I just wanted to explain a little bit what this is about, because when you're moving drones, stuff like airplanes or other types of aerial robots, you have to be careful with where is your z-axis. Okay, now why is this important? And this is a little bit of theory, but why not? Before we end the stream, we have where can I draw it? Let's just draw it right here. Wait a second. There we go. Yeah, there. So we have, the way we do it is this. Let's just create a robotic arm. Again, thankfully, I'm an engineer, not an artist. I wouldn't be like, yeah, I would be a very bad artist, but there we go. There we go, like this, okay? Every single joint follows the same roll, pitch, yaw, okay? Every single one has its own, like this, and probably here too. Okay, every single one of them has its own roll, pitch, and yaw. Okay, that means this arm can move like this. Yeah, so your arm can do this. And your arm, interestingly enough, can do this. Okay, because it's a ball-shaped joint. Okay, so it can do lots of movement. In the case of robotic arms, no. If you try to control it with, you know, it moves in the Z, but if you try to do it in, let's just think of your elbow. If you're just trying to move it in, like, should be roll, pitch. So you can actually do the same thing, yeah. Roll. If you try to roll it, okay, you can't actually. So it moves the entire bone, but the actual joint is not moving. Okay, just be careful not to hurt yourself. But yeah, so that won't work in a robot. Okay, so careful with roll, pitch, and yaw, because if you move a robot in X and that's not its Z component, you break it. Okay. Fun fact: have I broken robots like this? No, thank God no, because they cost like 1 million pesos, Mexican pesos, which is like $50,000. No, I'm not going to pay for that. But yeah, I just know the math. Just, you know, trust me. But yeah, so everything moves in Z, or basically everything rolls in Z. So whenever you're working with robots, okay, always the Z-axis is the one that turns in its own axis, okay? Never, ever, ever, ever turn in Y or in X, okay? You can break stuff. Cool. So far, so good. Nice, nice. I think that's everything that I wanted to cover. It's just an introduction to ROS. I know it's a little bit. It's half an hour before the stream should be ending. My voice is not as good as when I started 2 hours, three hours and a half ago. But yeah, trying my best. Let's see if I can do something else before we wrap today's ROS stream. Let's see. Publishers. Yeah, that's good. That's good. ROS topic. Yeah, that's fine. Wait a second. Listener talker. That's okay. The major project that we did it fast, which is really good. Yeah, I think that should be it. Yeah, I think that's it. Let's see. Let me just double check here if there's something that I can show you more. Okay, so for ROS, okay, the cool thing about this is that careful when you're just downloading ROS. Depends on your OS version, is that you can download the ROS version. Okay. Okay, cool. We have a question. Are you referring to specific robots that are pre-built or something that you would build? Oh, okay. So for this case here, okay, usually, okay, no. So let's rephrase that. Every single robot in every single robot in the world, okay, follows the same, or should follow the same, let's say the same laws, which is only rotating in Z. Okay, I'll get into what is ROS. Wait a second. So I've worked with robots that don't follow that convention. They work doing math on them. Okay, so if you go like 4 steps before, which I will never do a stream about that because it's not that easy. But if you go back some steps and do the core math of moving, basically, you cannot do it because it's not doesn't follow Z. So if that robot that is already pre-built, you bought it, and it doesn't roll on Z, it rolls on Y sometimes. I don't know, people just confuse Z and Y. Then your math won't work. ROS will work weirdly, but it will. But they usually follow the same Z component. Okay, make sense? Yeah. If it doesn't, I can say personally, it's not a good robot. Like it's not a good quality robot because the math wasn't done correctly. Okay, it's going back to the math, like robotics math. If you haven't studied robotics, I don't recommend you going through that math because it's really hard. But yeah, lots of matrices that if you just change one component, it changes everything. Okay, cool. We have an interesting question here. What is ROS? Okay, ROS, let's go up. ROS stands for Robotics Operating System, okay, which is an open source operating system for robots. But yeah, that's how it's done. Cool. We have another question here, which is, how do you set up the 4-window terminal on? And I'm so curious about the name of the ROS Udemy course. Yes, let me get back to that. First, let's take a look at the terminal. The terminal is called Tilix. Okay, you can see there. Wait a second. You can't see it. There you go. It says Tilix there. You can see it's a little bit hovered. Okay, when I open Tilix, it has this little buttons here. So I can click on this one and it created a little terminal. You can click another time and it's just a small terminal. Yep. So this is not the default terminal of Ubuntu. The default one looks like this. Let's see, I don't know. Open a terminal. This is the usual terminal that you get. You have this little button that allows you to have another terminal, like another how do you call this? It's not a terminal, it's a tab. Okay, so you have different tabs, but it doesn't really divide the mini terminals. So this one's the default one. I never use it for ROS. I actually never use it because it's not that intuitive. I use Tilix. Tilix is really good, and you can personalize it and all of that. There's another one called Terminator, which does the same thing. Okay, so it's up to you. Yep, cool. Nice. Sorry about that. Let's see. Where do you typically buy cheap robots? Oof. I won't say the brands. I won't dox myself like that. Amazon. Probably. Amazon, yeah, could be. It depends on the brand. Like, if it's a robot that is ROS compatible and it's cheap, just make sure to read like the papers or the sheets, and just make sure that the sheets mention that the component that's in charge of the rotation, it's Z. Okay, so it's you can see that it's, even if it's a cheap robot, it's a good quality robot. But yeah, cheap robots are usually found on Amazon or I don't know, other online shops. Like if you wanna go, if you go to Amazon and just check the brand and go to that brand's page, you can find it there. I don't have any specific brand that is actually cheap and good. Robotis, which is the one that created the Turtlebot, is good. It has humanoids and the robot and arm. It has an arm too, so you can it's ROS compatible, so they're good. They're not that cheap though. Like the robot costs like, it's like 15,000 Mexican pesos, which is $750 ish. But yeah, that's where you can buy like cheap robots. Okay, cool, 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 cool. Nice. So I think I'll stop the stream now because we completed everything. My voice is dying. But yeah, I'm so happy that you were able to join. Again, I'm sorry that I'm finishing this stream a little bit earlier, but yeah. Any final questions? Oh, actually, before that, wait a second, just in case. Control C, no. Let's do this. Just in case, yes. Wait a second, I need to get that for you. Wait a second, let me just put this computer here. The Udemy course that I took, didn't complete though, but I took for the core, knowledge for ROS was, wait a second, let me just remove this. It's this one. Wait a second. Let me just get my Udemy. Wait a second. Open my personal account. Me. Oops, sorry. Continue as me. Yes. Give me a second. Come on, Udemy. Oh, come on. Okay, it's loading. Can I do Udemy ROS? Ah, there we go. There it is. So this one is really good. Yeah, I recommend this one. Udemy courses are really cheap, so I really like them. It follows a very good, let's say, pattern of teaching. So this guy's really good. The only thing that I would probably change about this course is that sometimes it oscillates from Ubuntu 16 to Ubuntu 20. Just because I think it was recorded in different times, like different eras, so to speak. So one was recorded like 2 years ago, another video was recorded like 2 months ago. So just don't get messed up with that change. But the course is really good. It covers a lot of basics. So yeah, it's really good. Definitely check it out. But yeah, if you don't have Ubuntu, make a partition, or preferably have a virtual machine before, so you don't mess with your computer's memory and all of that. Okay, cool. Yes. Any final questions? By the way, please, if you could answer this. Let me get it first. Please give us some feedback here. And yep, there we go. Cool. So I think that'll be it. Thank you all for joining. The next stream is about Intro to RESTful APIs with Alberto. Starts in 2 hours, an hour and a half. Yes. So make sure to check Alberto's cool stream again in 2 hours. And yeah, I think that's everything. Thank you for joining. Ping me on Discord, on LinkedIn, and yep, I'll be able to help. And yep, thanks for joining, and have a good one. And we'll be seeing you in like 4 days. I'll be streaming Intro to C++. Okay. Thank you. Bye bye.